Hi everyone. Today we will start a new chapter, the chapter 4, with the section about talking about distance, midpoint, and the gradient review. So first of all, we should know that the formula, if we have 2 points in the plane, in 2D plane, okay, 2 points we mean, each point is represented by coordinates. So we mean an abscissa and an ordinate. So normally if we have 2 points, we can measure the distance between them. Using this formula, distance equal to square root of the difference, the square of the difference of the abscissas plus the square of the difference between their ordinates. So easy. If we have the coordinates of 2 points, okay, so normally we apply this formula as we see here, okay. So d equal to the big, this long square root, and x2 minus x1 squared plus y2 minus y1 squared. So normally we should find the difference between abscissa. We can use 2 minus 5 or 5 minus 2 because the difference is used as the square of the difference. So normally if we say 5 minus 2 squared or we say 2 minus 5 squared, it is the same. Okay, and similarly to when applying or when evaluating the difference between our ordinates 6 minus 1 or 1 minus 6 squared, because the squared will ensure us to have a positive value inside the square root. So we'll obtain, using the calculator, our 3 squared is equal to 3 by 3 is 9, and minus 5 by minus 5, normally it is a 25, and then we evaluate sum, and we will obtain radical 34 units of length, because we are evaluating the distance between these 2 points. Easy. And the following exercise, we have different pair of points, which we are seeking to find the distance between each pair given here. So normally in the part E, we have a point PQ. So normally we are seeking to find the length between the point P and Q. So we can, for example, use the same formula, the square root of the difference, 1 minus 4, because we have minus, and the abscissa of the second point is minus 4. All the as a group or as a factor square plus minus 2 minus 3 squared. Normally we will obtain minus inside the first square group squared. Minus is equal to plus 4, and 1 plus 4, 5 squared plus 5 squared. So we'll obtain radical 50, and radical 50, if we decompose it into primary numbers, so normally we will obtain 5 radical 2 unit of length. What about the midpoint of a line? Normally a straight line, normally we can't find the midpoint of a straight line. But if we're talking about segment, why? Because a line is going to go to the minus to the plus infinity, go to grow in both sides. Okay, if we have we are talking about this line, so we can use an arrow here and the two ends, both ends, to represent that this line can grow from this direction and in this direction. So we can't find the midpoint of a line, but if we have a line segment, the difference between line and line segment, the line segment is restricted to the 2 points and to 2 end points. Okay, so normally, if we are going to find the midpoint of a line segment, so we have the two endpoints of this segment. Okay, so we can use the average of their abscissa x1 plus x2 squared as the abscissa of the midpoint of this segment, and the average of their ordinate y1 plus y2 over 2 to represent the ordinate of the midpoint. It is easy to represent it here. Use in any plane. So x1, y, this point and this point. We are seeking to find the midpoint here. Okay, the midpoint here normally has as ordinate this one is ordinate and this one is ordinate. Normally the average. So the x coordinate of the midpoint of an interval is the average of the x values of the endpoint. Similarly, the y coordinate here, easy. So if we have 2 points and their coordinates, we can easily calculate it. For example, -4 plus 8, it is 4 over 2, 2. So normally 2 is the abscissa of the midpoint of the segment AB. And the 3 plus -2 equal to 1 over 2. So 1 over 2 is represents the ordinate of the midpoint of the segment AB. And similarly, in the following exercises, we can use the same formula to, for example, find the midpoint of the join of any pair of points given in the exercise 4. But in the exercise 6, we have a resemblance, or we can say we can use the formula to find any unknown. Like this case, we have the midpoint of AB. So we have a segment AB, and we have the coordinates of the point P are unknowns, variables. We are going to find the coordinate of B when this point with coordinate 5 minus 4 at the midpoint of the segment AB. So normally, what we know that if 5 as abscissa of the midpoint equal to the average 3 plus x2 over 2. So 3 plus x2 over 2 equal to 5. So we can use the cross multiplication, or we can multiply both sides by 2. If we multiply both sides by 2, we'll after simplification from left side by 2 and 2, we will obtain 3 plus x2 equal to 5 by 2. In this case, we can move the numerical or the numbers to the right-hand side and any variable, any pronumeral to the left-hand side. And when moving it, the positive becomes negative and the negative becomes positive. So we can replace it or we can move it as the opposite in the other hand side of the equation. So normally we have a plus 3, it becomes -3 in the right-hand side of the equal. So we'll obtain 10 minus 3 equal to 7. Or we can say easily, we want to get rid from 3 from the left-hand side of the equal. So normally 3 plus 3, we subtract or we add -3 on both sides of the equal. So when adding -3 here, so we cancel 3 from here, and we'll obtain 10 minus 3 in the right-hand side of the equal. And similarly, -4 as ordinate of the midpoint equal to the average of -2 plus y2 over 2, and cross multiplication. We have under -4, we can put 1 to resemble to a fraction, and then -2 plus y squared equal to -4 by 2. And then, as we said before, we move -2 to the right-hand side of the equal. So normally -2 becomes +2 to obtain finally y2 equal to -6. And this exercise is very similar to the exercise, to the idea of the exercise 6. What about the gradient of a straight line? Normally, the gradient of a straight line gives us some idea about the variation of the line. If the line is increasing or decreasing, normally we can say that the line is increasing or going up Going up, so we say this way is going up because the x-axis growth in this direction. When the x-axis growth of this direction, normally we start to evaluate the growth of the line from the left to the right. So normally the line growth is increasing in this way, and when x is growing in this direction, so normally we say that if the line is straight from here, so it is increasing in this way. So when the gradient is positive, we say that the line is increasing and going up, and when the gradient is decreasing, we say that the line is decreasing. The gradient is negative, so the line is decreasing, and we say that the line is going down. Okay, so easy. We need to find the gradient of a straight line. We need any 2 points of this straight line. So if we can find the coordinates of any 2 points, we can, for example, using the rise over the run. How to find the rise? The rise is the difference between the ordinates, and the run is the difference between the abscissa. So y2 minus y1 over x2 minus x1. And you can use this one reversely in any order. But if we start by the ordinate of the second point, we should start by the abscissa of the second point first in the denominator. So get it? In this example, they ask us to use the gradient formula to find the slope. So the slope is the gradient passing through the points A and B. So normally m equal to y2 or minus y1 over x2 minus x1. So y2 7, or we can start by the point B 3 minus 7 over, if we start by B 7 minus 4. So 7 minus 4, and we can 3 minus 7 is minus 4, and 7 minus 4 is 3, and so we will obtain as a gradient minus 4 over 3 when the gradient is negative, so the straight line is decreasing. And also similarly, we have the same idea in the exercise 10, and you can complete all the rest of the exercises by yourself, easy, using the midpoint and the gradient formula, and also the midpoint formula, the gradient formula, and the distance formula. Thank you for listening. Bye-bye.